Hi, everybody. I want to make a little video on the Pythagorean Theorem, and I want to talk about the Pythagorean Theorem first before I get into it. But I've been teaching, for actually, I guess, 3 decades at this point. And, whenever for the past 10 to 15 years, on the first day of class, I always ask, what's the Pythagorean Theorem? And everybody tells me it's a squared plus b squared equals c squared, which is exactly correct. In a right triangle with legs a, b, and hypotenuse c, the sum of the squares of the legs is equal to the square of the hypotenuse. So a squared plus b squared equals c squared is a statement of the Pythagorean theorem, and I think that's awesome. However, I then follow it up with the question, why is it true? And everybody's a little, usually dumbfounded, to be honest. And once in a while, I've had students that actually say they asked their teacher, faculty member, instructor, whatever, why it's true. And generally they have not received a response, but at least they asked. And because my job at this point, when I teach, is to share enlightenment, right? And so if no one's curious, then it's much harder to share, right? So so I try to stimulate that enlightenment, and that's what these videos essentially are about. I think I'm picking out some pretty cool topics, actually. Elementary topics of math are topics that are actually not simple. It means they don't need any heavy machinery to solve them, right? So elementary topics, whenever somebody says elementary topics of math, watch out, because it's usually pretty not so simple. These aren't that complicated. In addition, one thing I want to talk about is the name Pythagorean. So, the theorem is named after the Pythagorean school. It's not named after Pythagorean himself. Essentially, it was a commune of intellectuals that lived at this school, and they published lots of results, including this one. And the concept was that ego was an issue for people, so they didn't want anyone's name to be associated with these results that they produce. So hence, everything was named after the school itself, right? And that way it kind of kept everybody humble, right? Which is very important, actually, I do believe. So that's a little bit of history on the Pythagorean theorem. And this is a statement of the Pythagorean theorem. So now the question is, why is it true? And so let me scroll. I made a little picture. And, when I do this in class, let me zoom out a little. Okay, when I do this in class and I put this square on the board, and everybody right away says, "Oh my God, Jan, what are you doing? You're drawing a square. This is triangle stuff. Come on, Jan." And it's okay, because then I create this little, square within a square, actually. And at the end of the day, I have 1, 2, 3, 4 of these ABC triangles, right? With legs A and B, a hypotenuse C. So it's nice. So actually, instead of dealing with one of this object that I need to understand, I actually have 4, and I have a little extra, because this is C, this is C, this is C, right? So I have a square inside. And so my goal is to show that a squared plus b squared equals c squared, for an arbitrary triangle with legs A, B, and hypotenuse C, for an arbitrary right triangle, excuse me. And so I'm going to look at the area of the structure that I just drew, this square. And I can look at the area in a couple different ways. So I'll write it on the right. The area, first of all, is, for any square, or any rectangle or whatever, what we usually say is base times height. And sometimes we say length times width. They're all the same. Essentially, it's one dimension times the other. And the one dimension you can see is a plus b. And the second dimension, whatever you want to call it, the width, the height, it doesn't matter, is also a plus b. And so it's really nice, because I just made a video on the FOIL method. And what do you do with this? You FOIL it out, So by FOILing, I get a times a is a squared, then the outside is ab, and then the inside is ba, which, just for clarity, these two are the same vis-a-vis the commutative property of multiplication. You can multiply in any order. And, the last is b times b, which is b squared. So, and then this is, this is the area. And since these two are the same, I'm just going to rewrite this as a squared plus 2ab plus b squared. And here I get some, usually when I'm teaching, I get some suspects. What do you do? And yeah, we don't need area. It's good, good, good. And I say, well, we can look at the area in that manner, and we can also look at the area in a different way, right? We can actually add, the triangles, these four triangles, as well as the area in the square. And the area of a triangle generally is, I guess we usually call it base times height times a half, or length times, like you could say, essentially it's just one dimension times the other dimension divided by two. And the reason, it's divided by two is because it's half of a parallelogram, right? That's where the formula is derived from. So essentially the formula of one triangle is AB divided by two. And so since I have four of them, I'm going to multiply it by four. In addition to that, I have this, square inside with side C. And as mentioned before, the area will be C squared. And if you multiply this, this gives you 2. So the area is going to be 2AB plus C squared. And this is awesome. So I have the area is this, and the area is also this. And these two things must be the same, right? The area is constant, right? So we have A squared plus B squared, plus 2AB, excuse me, plus 2AB plus B squared equals 2AB plus C squared. And now you can kind of see, subtract 2AB from both sides, right? This disappears. At the end of the day, what we're going to have, let me try to scroll down a little bit if I can. Okay. And what we have is A squared plus B squared is equal to C squared. And so in a right triangle with legs AB and hypotenuse C, we can actually prove that the sum of the squares of the legs is equal to the square of the hypotenuse. And that is it. That is the proof of the Pythagorean theorem. Thank you very much for watching. Appreciate it.